This section is about something called piecewise functions as well as continuity. And so the first thing we need to do is look at what exactly is a piece function. A piece function is defined by two or more function rules for various intervals of its domain. Just an easy way of saying they took pieces of different functions and put them all together into one function. So we're going to talk about a couple of functions and then we're going to look at some piecewise. Just as a reminder, an absolute value function means that if x is greater than 0, you use that number, and if x is less than 0, you use the opposite. So all of these negative x's, you're going to have a positive y. All of these positive x's, you're going to have a positive y, which forms this V shape for this particular graph. So let's talk about the term continuous, a function that has no gaps, no jumps, no holes. It is a continuous function. So when you have a continuous function, you can graph that function without lifting your pencil off of that paper. So let's look at an example of a piecewise function, and we're going to see whether or not it is continuous. So the first piece of this function is right here. It says, I want you to graph an x squared function as long as x is less than or equal to -1. So the first thing I typically do is I go find that less than or equal to -1. So I'm going to find that -1 on my graph, and I am going to highlight it just as a reminder that I am graphing from this point below. And then I'm going to think about what is an x squared graph? Well, if you remember, x squared is a parabola, and x squared with no plus or minus or anything is just a parabola right on the 0, 0 origin. And so if I were to graph this, I'm going to just dash this and graph just a regular old parabola right here. And so that's what that parabola would look like if that's what I was graphing. But remember, they specifically told me that I only want to do this for less than -1. So I need to start at -1 and only go on the less than side. Well, the other thing I have to determine is, does it include -1? And yes, it does. So just like our old school graphing on a number line, if it includes that -1, we are going to put a solid dot there, and then we are going to actually graph it. This is where my graph is, right here. Now, it does not include anything greater than -1, so I do not need this side of the graph. I only need that side, but that's where that piece came from right there. Let's look at the next piece. So the next piece is an absolute value function, just like we looked at a minute ago. But on this one, we are going from -1 to +2. So if I were to graph an absolute value function here, it would look like this. This would be my absolute value function. However, it specifically said that it wants me to start at -1 and go until I get to 2. And so I'm going to once again highlight right here at that -2. I mean, excuse me, at that +2. And I'm going to say, well, I only want from -1 to 2. Now, in this case, it doesn't include -1, but I've already included -1 on my graph. So I can leave that dot there because it was included in the first piece. And I can say, well, now I only want from here until I get to that 2. And once again, I'm going to say, well, does it include 2? Yes, it does. It is or equal to. And I do not need the rest of this graph right here, so I can get rid of that. That's the second piece. And now I'm going to look at my third piece. My third piece says -x plus 5, anything bigger than 2. Now, if you remember, -x plus 5 is just a line. It's just a line graph. However, this particular line graph has a negative slope, so we're going to have to remember those pieces. Remember, we start at 5. That's my y-intercept. And I go down by 1. So I'm going to go down 1 over 1, down 1 over 1. This is what my graph would look like for a line. So if I were to just graph this line, it would look like this, right? That's my negative x plus 5 line. However, once again, this only wants me to graph greater than or equal to 2. Now, I do have 2 right here. However, this linear graph crosses right here at 2, and it doesn't include it because it's just greater than. So I need to do an open circle there, and everything greater than is what's actually part of my graph. So this graph is going to go this direction for this piece. And those other pieces of that linear graph I no longer need. So this is the graph of my piecewise function. Now let's talk about whether it's continuous. Well, it's continuous here. It's continuous up to this point, but I could not have just taken my finger and gone along this graph and stayed. Right here, I have a problem. If I were riding a roller coaster, this would be an issue here. So this whole graph is not continuous. And we'll talk about pieces of continuity. And this piece could be continuous, but this is not continuous right here. But overall, this graph is not continuous because of this jump. And so piecewise function are very often discontinuous, but not always. You just graph them a piece at a time. This piece was a parabola. This piece was absolute value. This piece was a line. So what I'd like you to do is I'd like you to pause the video and I want you to try to graph this piecewise function. And then once you have tried it, start the video back. You'll see the answer on the screen. You'll want to check your answer against this graph. The first one looks like a line, but it's actually absolute value. Had I gone all the way down here, you would have seen that. So we have this piece less than or equal to -2, closed circle here. We have a negative slope graph, just a linear graph from 2 to 3. It did not include either endpoint, so open circle there. And then we have a positive slope graph, x minus 4. If I plugged in that 3, I would get to -1 here and then choose another point. You'll notice that the ends have those arrows indicating that it is continuous on from that point. And if you have trouble, you can just plug a point in. So you can plug in this -2. That would give you a +2. Plug in a number over here and you can see it. Plug in your endpoints and you can see where those would be. -2 right here. So we get your 5, -2 plus 3 is 5. Plug in a 3, -3 plus 3 is 0. So you can see those 2 points would be the endpoints there. And then again, you can plug the 3 in here. 3 minus 4 is -1, and you can keep going from there. But you can also see that this is not a continuous graph. It's just 3 pieces. They do not connect. As we continue to talk about piecewise functions, it's important to review some of the common, what's called parent functions that we would use to graph the piecewise functions. Now, a lot of these are going to be familiar, and we'll be adding more as we go along. When we get to stretching and skewing and moving these around the graph, that will also become important. But some of the ones you should be familiar with is your constant function. This is just like y equals a number. In this case, y equals 4, and that's just a horizontal line. Or your standard linear function, y equals mx plus b. The absolute value function we've already talked about. It looks like that v. Your quadratic, your parabolas, you should be familiar with right there. And then some other ones, a cubic function is just a graph that kind of looks like if you were to take half of a parabola down here and the other half up there. The square root looks like a parabola that's in half sideways or just half of those on the top part because it is always positive. A cubic, well, that can be negative. So you have again what looks like a cubic function over here that's kind of been turned and flipped a little bit. And then some of the others that we are going to get to later in the year are exponential and logarithmic functions. And then very quickly, we will move to rational functions like that. For right now, for your piecewise function, I want you to concentrate on your constant, linear, and absolute values. And then this second row, just to about the square root right here. So your quadratic, your cubic, and your root. Because at any time you could actually have a piecewise function that included any one of these and just a piece of them. And so it's much easier if you get a visual as to what that graph looks like so that when you get to that part of the piece, you can really just sketch it because that's what you're doing when you do these piecewise functions. So let's look at some of these examples of piecewise function. Again, when you're graphing these, the best thing to do is to think about dividing that graph into the pieces that you are trying to graph individually. And so what I like to do is I like to take these and start with that first one. And I'm going to say, well, where does it divide this graph? And so this particular one is everything less than or equal to 0. And so I'm going to draw that or shade that vertical line at the 0 and know that I'm looking at everything to the left of it. Well, then the next piece here is to figure out what kind of graph I have. Well, this is an absolute value graph. And so I need to remind myself that an absolute value graph looks like that. And if I were to remember my movement, which we'll review again in this chapter, that absolute value graph is going to go down by 1 because I'm subtracting 1 there. And so if I were to just graph this absolute value function, which we have done movements with absolute value functions before, it would look like that. However, I'm only talking a part that's less than 0. The other thing I want to do is where's my starting point here? Well, you can always plug your starting value in. You can say 0, absolute value of that minus 1, and you can see that you would be at -1. And I am putting a solid circle there because it is included. And then I'm going to go ahead and graph the piece that is less than 0. That's part of my graph. And then I no longer need this. This was just to help me sketch it because I'm only going up until 0 for that piece of the graph. And then I'm going to move on to the next piece of the graph. This next piece goes from 0 up to 4. And so I'm at 0 and I'm going to sketch that vertical line at 4. And there's my next piece that I'm going to graph. Well, this one is also a familiar graph. This is a parabola. And you can always refer back to that parent function while we go through these, but this is a parabola. And remember, inside the parentheses, you move opposite and you move left or right. In this case, we're going to move right. Remember, it's the opposite. So this would be a parabola that would start at this 2 right here, and that would do something like this. This would be the parabola. It would look something like that. And again, to make sure, you can always plug the 0 in to see the left-handed side, 0 minus 2 quantity squared. Well, you can see that I'm actually a little bit off. At 0, I would be at 4. And so you can see when I'm graphing that I was just sketching and I'm a little bit off. So I would actually be at this 4. And in this case, it's just less than. So at that 4, it actually doesn't include it, right? So I'm just going to use an open circle because that 0, 4 is not technically included. And then I can plug in the other endpoint and I can say 4 minus 2 quantity squared. That's also a 4. And again, you can see that I was a little bit off when I sketched that piece of it. And so I can just fix that and say, well, over here, I would be at +4. And that is inclusive because it was or equal to. So this piece is going to be this parabola right here, and I'm going to stop at the end of my pieces. And I'm going to do the same exact thing with this next one. I am looking at x minus 1 for everything bigger than 4. Well, x minus 1, if you remind yourself, that's just a linear graph, right? Y equals mx plus b. In this case, my b is -1, and my slope is +1. And so it would usually have this little line that goes all the way here, right? But I'm just going to plug that 4 in, and I'm going to say, well, at the point 4, plug it into that function, my y value would be 3. So I know the 0.43 is going to be here. It is just greater than, so I'm going to do an open circle at that 3. And then with the linear graph, you can really pick any other point. Let's say 6. If I were to plug in a 6, 6 minus 1 is 5. So the 0.65 would be on this graph, and you can just graph your linear equation from there. And so I have my three pieces. I have my absolute value piece right here. I have my quadratic or my parabola piece right there. And I have my linear piece right there. And I've successfully graphed the piecewise function. So what I'd like you to do is I'd like you to pause the video so that you can try this one on your own. And then when you're ready, go back and check your answer.